Hi folks. In this video, we're going to introduce the idea of limits. To do this, we'll use the example function f of x equals sine of x divided by x. The first thing I want to notice is that the function f has a domain restriction. Namely, I can't plug in x equals 0 because this would mean division by 0, which we know is undefined. So, the domain of my function is all real numbers except x equals 0, which I can write in interval notation like this. Now, in calculus, we'll often be concerned with the question, what happens as I plug in values of x nearby a particular point? So in this case, I'm not actually concerned with what happens when I plug in x equals 0 exactly, well, because that doesn't make sense. But instead, I can ask the question, what happens when I plug in values of x, which are very close to 0? So, using a calculator, I did exactly that. I took x equals 1 and plugged it into the function sine of x over x and got 0.84 out on my calculator. Plugging in x equals 0.1, I got an output 0.99. Plugging in x equals 0.01, I got an output 0.9999, and plugging in a value x equals 0.001, I got an output 0.999999. Okay, so notice, I'm not plugging in x equals 0. I'm plugging in values nearby 0, things getting closer to 0. And what I notice is a pattern emerge. Right? I notice the outputs are also getting close to a number, namely 1. So again, as x gets closer to 0, but not actually equal, right? As I get closer to 0, the values f of x get closer to the number 1. And this is what it means to take a limit. A limit means not to plug in the value x equals 0, but to plug in values nearby 0 and see what happens to the outputs. Now, instead of writing this sentence over and over, what I'm going to want to do is introduce a notation which means exactly this English phrase. Now, the mathematical notation we use is limit notation, which is lim, which stands for limit, as x goes to 0 of f of x equals 1. That is to say, if I take x values, which are getting closer and closer to 0, the f of x values get closer and closer to 1, which is what this table is telling us. So you see the power of limits. It allows us to tell more of a story than plugging in the value x equals 0 exactly, right? The idea of limit is to not plug in 0, but to plug in values close to 0. Written another way, let's think about this as a graph. So I used Mathematica and I plotted the function f of x. In fact, it did a pretty good job, but it did make a small mistake, right? Mathematica actually filled in this hole here, but we know, because of the domain restriction of my function, x can't be equal to 0. So there actually should be a small hole at x equals 0 on my graph. But that being said, we do notice that there's a pattern, sort of like a nice behavior, that as x becomes closer and closer to 0, the values that I get when I plug in those very close to 0 numbers become closer and closer to the number 1. Again, I'm saying that the limit as x approaches 0 of my function is 1. So, if you have any questions about this idea of limits, right, please come talk to me in office hours or before class, and we'll just continue this discussion in class.